Let us now take the third module from this topic of number systems. In some of the questions from this topic, the divisibility test has to be conducted. That means we need to check whether the given number is divisible by a particular number or not. So in order to simplify these questions, we need to know the various rules which are to be followed to check the divisibility of the given number with various numbers. So let us first understand the divisibility rules for different numbers. Now if you look at the first one here, divisibility by 2. How to check whether a given number is divisible by 2 or not? The condition here is the number should be even. So for a number to be divisible by 2, it has to be an even number. Or we can say that the last digit should be even. So it should be either 0 or 2 or 4 or 6 or 8. But because only in these cases the number becomes an even number. Now if you look at some examples here, the number 2796, this is an even number, or the last digit here is 6, which is even. So obviously the number itself is an even number. So this number is definitely divisible by 2. Why? Because all the even numbers are multiples of 2. So once it is an even number, it becomes a multiple of 2, and hence it is definitely divisible by 2. So 2796 is divisible by 2. Similarly 174, the last digit here is 4. That is again an even digit. So 174 is an even number. So even this is divisible by 2. But when we look at this number 3791, this is an odd number. And very clearly we know that for a number to be divisible by 2, it should be even. And since it is an odd number, we can say that this is not divisible by 2. So this is how we can verify the divisibility by 2 by simply checking the last digit of the given number. The next one here is divisibility by 3. So how to check whether a given number is divisible by 3 or not? The rule here is the sum of the digits of the given number should be a multiple of 3. So for a number to be divisible by 3, the sum of its digits, the sum of all its digits has to be a multiple of 3. Let us take some example and understand this. Now let's say the given number is 689154. How to check whether the given number is divisible by 3 or not? What we do here is add all the digits. And the sum, if it is a multiple of 3, this number is divisible by 3. Otherwise, it is not. Let us check what is the sum of these digits. 6 plus 8 is 14. 14 plus 9 is 23. Plus 1 is 24. 24 plus 5 is 29. 29 plus 4 is 33. That means the sum of all these digits here comes out to be 33. And we know that 33 is a multiple of 3. Why? Because 33 is 3 into 11. So if 33 is a multiple of 3, then this number is definitely divisible by 3. Why? Because the sum of its digits is a multiple of 3. Let us now see whether this number 32147 is divisible by 3 or not. Again, we need to find out the sum of the digits. 3 plus 2 is 5, plus 1 6, 6 plus 4 is 10, and 10 plus 7 is 17. 17 is not a multiple of 3. So this number is not divisible by 3. So this is how we can check the divisibility of a number by 3 by finding out the sum of its digits. If the sum is a multiple of 3, then the number is divisible by 3. Otherwise, it is not. Let us now move to find out the divisibility rule for 4. Now for a number to be divisible by 4, the number formed by the last two digits of the given number should be a multiple of 4. So this is how we can check the divisibility by 4. Whatever number is given to us, we need to take the last two digits. That means units place and tens place. And the number formed by these two digits has to be a multiple of 4. Let us see some examples here. For example, 389416. If you look at this number, the last two digits here are 16. And because 16 is a multiple of 4, this number is divisible by 4. So simply to check the divisibility, we need to just check the last two digits. If it is a multiple of 4, then the number is divisible by 4. Otherwise, it is not. Now if you look at the next number here, 598127, the last two digits here are 27. So the number formed by the last two digits there is 27. And 27 is not a multiple of 4. So hence, this number is not divisible by 4. So simply for a number to be divisible by 4, the last two digits have to be a multiple of 4. That means 4, 8, 12, 16, 20, 24 and so on. So this is how we can check the divisibility by 4. Now moving on to the divisibility by 5. For a number to be divisible by 5, the last digit of the number should be either 0 or 5 itself. So this is very simple. We only need to check the last digit. If it is 0 or 5, then the number is divisible by 5. Otherwise, it is not. So some simple examples here are 18975. Here the last digit is 5. So this is divisible by 5. In second example 32690, the last digit is 0. So hence this number also is divisible by 5. But in the last case here, that is 1,87,173, the last digit is 3. And hence we can say that this number is not divisible by 5. Why? Because it should either be 5 or 0 for it to be divisible by 5. So this is how we can verify the divisibility of 2, 3, 4 and 5. The next one here is divisibility by 6. Now a number is divisible by 6 if it is divisible by 2 and 3. So for a number to be divisible by 6, it should be divisible by 2 as well as 3. And we have already learned the divisibility rule for 2 and 3. That means for a number to be divisible by 2, it has to be an even number, because that's the divisibility rule for 2, and at the same time the sum of its digits should be a multiple of 3. Why? Because that is the divisibility rule for 3. So when both the divisibility rules of 3 and 2 are satisfied, then the number is divisible by 6 as well. For example, if you look at the first one here, 918654, this number is divisible by 2 because the last digit here is even, or the number here is an even number. So it is divisible by 2. Let us now check the divisibility of this number by 3. Now we know that divisibility for 3 is sum of the digits has to be a multiple of 3. So sum of the digits here, 9 plus 1, 10, 10 and 8, 18, plus 6, 24, plus 5, 29, plus 4, 33. So this number 33 is a multiple of 3. Hence, the given number here is divisible by 3 also. So as it is divisible by both 2 and 3, we can say that this number is divisible by 6. Moving on to the next example, 43172, that is 43,172. Now as the given number is even, it is divisible by 2. Let us now see the divisibility by 3. 4 plus 3 is 7, plus 1 8, plus 7 15, plus 2 17. 17 is not a multiple of 3. Hence, this number is not divisible by 3. So we can see that the number given here is divisible by 2 but not by 3. Hence, it is not divisible by 6. Why? Because for it to be divisible by 6, it should be divisible by both 2 as well as 3. Now in the third example here, 69321, the number is odd, and hence we can say that it is not divisible by 2. And once a number is not divisible by 2, it will not be divisible by 6 also. So even this number is not divisible by 6. Let us now see what is the divisibility rule for 8. Now for a number to be divisible by 8, the number formed by last 3 digits of the given number should be a multiple of 8. So that's like 4. In case of 4, we see that the last 2 digits have to be a multiple of 4. But in case of 8, the last 3 digits have to be a multiple of 8. Only then the given number is divisible by 8. Let us take some examples and understand this. The number here is 13840. So the last 3 digits here are 840. So the number formed by last 3 digits is 840. And 840 is a multiple of 8. So we can say that the given number 13840 is divisible by 8. Now if you look at the next example here, it is 643151. The number formed by the last 3 digits 151 is not a multiple of 8. Hence this number is not divisible by 8. So simply to check whether the given number is divisible by 8 or not, we need to just verify the last 3 digits. If the last 3 digits form a multiple of 8, or if they are divisible by 8, then the complete number is divisible by 8. Otherwise it is not. Moving on to the divisibility rule for 9. Now, for a number to be divisible by 9, the sum of the digits of the number should be a multiple of 9. So that's exactly like 3. In case of 3 as well, we see that if the sum of the digits is a multiple of 3, then the number is divisible by 3. Let's take some examples to understand this. The number here is 9516348. So that's like 95,16,348. Now that's a huge number. And to check whether this is divisible by 9 or not, in the general procedure would take a lot of time. So instead of that, simply check the sum of the digits. So 9 plus 5 is 14, 14 plus 1 is 15, plus 6 is 21, plus 3 is 24, plus 4 is 28, and plus 8 is 36. That means sum of the digits here is 36. And 36 is a multiple of 9. 9 into 4 is 36. So as the sum of the digits here is a multiple of 9, we can say that the given number is divisible by 9. The other example here is 172356. Let us see if this number is divisible by 9 or not. The sum of the digits here, 1 plus 7 8, plus 2 10, plus 3 13, plus 5 18 plus 6 24. 24 is the sum of the digits, and we very well understand that 24 is not a multiple of 9. So we can say that the given number here is not divisible by 9. So that's how we check the divisibility for 9. The sum of the digits have to be a multiple of 9. Moving on to the divisibility rule for 10. For a number to be divisible by 10, the last digit of the number should be 0. So like in case of 5, the last digit has to be 0 or 5. But in case of 10, the last digit should be only 0. Only then the number is divisible by 10. If we take some examples here, this number 4953270, we find that the last digit is 0. Hence, directly we can say this number is divisible by 10. But if you look at the number 137736, the last digit is 6. And hence, this number is not divisible by 10. So that's how we check the divisibility for 10. Let us now learn how to check the divisibility by 11 and 12. A number is divisible by 11 if the difference between the sum of the digits in alternate positions should be a 0 or a multiple of 11. So for a number to be divisible by 11, the difference of the sums of the digits in alternate positions has to be 0 or a multiple of 11. Let us understand this with the help of some examples. Now, as you can see here, the number is 275. What we need to do here is find out the difference between the sums of alternate positions. For example, we have to first of all find out the sums of alternate positions. So 2 and the alternate position is 5. So 2 plus 5 is 7. So sum of these alternate positions here is 2 plus 5, which is equal to 7. And the other left out position is only 1, that is 7. So the sum itself can be taken as 7. Now we see that one of the sums is 7, the other sum is also 7. And the difference between these two sums, 7 minus 7 is 0. So as given here, if the difference is 0 or a multiple of 11, the number is divisible by 11. So we can say that 275 here is divisible by 11. Let us take one more example to understand this. As given here, we first need to find out the sum of alternate positions. So let us find out the sum of alternate positions here. 6 plus 7 plus 8 plus 2. So as you can see, we are taking all the alternate positions. 6 plus 7 is 13. 13 plus 8 is 21. 21 plus 2 is 23. So one of the sums is 23. Let us now take the sum of the other alternate positions. 4, 3, 2 and 3. 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 3 is 12. So the other sum here is 12. And the difference between these two sums, 23 difference 12, is equal to 11. Now since the difference is 11, we know that the difference should be either 0 or multiple of 11 for the number to be divisible by 11. So since the difference here is 11, it is nothing but a multiple of 11. So we can say that even the second number here is divisible by 11. So that's how we only need to find out the sums of the alternate positions and then take the difference between these two sums. If it is 0 or a multiple of 11, then the number is divisible by 11. Let us take one more example. Here the sum of alternate positions, 8 plus 9 plus 0. 8 plus 9 is 17 plus 0 is 17. And the other sum, that is 1 plus 2 is 3. 17 difference 3 will be equal to 14. And since 14 is not a multiple of 11, we can say that this number is not divisible by 11. So that's how we check the divisibility for the number 11. Let us now see the divisibility rule for 12. For a number to be divisible by 12, it has to be divisible by both 3 and 4. So the simple point here is, if a number is divisible by 3 as well as 4, then it is divisible by 12. Let us check this with some examples. We already know the divisibility rules for 3 and 4. A number is divisible by 3 if the sum of the digits is a multiple of 3. And it is divisible by 4 if the last two digits make a number which is multiple of 4. So let us check which of these numbers satisfy both the conditions. Now since it is easy to check the divisibility for 4 when compared to 3, let us first check the divisibility for 4. Now if you look at the number here 13764, the last two digits are 6 and 4. That means the number formed by the last two digits is 64. And 64 is a multiple of 4. 64 is nothing but 4 into 16. So this number is divisible by 4. And if 64 is divisible by 4, then the complete number is divisible by 4. Let us now see, is it divisible by 3 or not. Now for 3, we need to check the sum of the digits. 1 plus 3, 4. 4 plus 7 is 11. 11 plus 6 is 17. Plus 4 is 21. That means the sum of the digits here is 21. And 21 is a multiple of 3. So this number is definitely divisible by 3. So as we have seen here, it is divisible by 4 as well as 3. So we can say that this number is divisible by 12. Let us now take one more example. 415276. Here the last two digits are 7 and 6. So the number formed by the last two digits is 76. And 76 is a multiple of 4. So this number is divisible by 4. Let us see, is it divisible by 3 or not. 4 plus 1, 5 plus 5, 10 plus 2, 12 plus 7, 19 plus 6 is 25. So sum of the digits here is 25. And 25 is not a multiple of 3. Hence, this number is not divisible by 3. And if it is not divisible by 3, even though it is divisible by 4, then it cannot be divisible by 12. Why? Because for a number to be divisible by 12, it should satisfy the conditions for 3 as well as 4. So the condition for 4 is satisfied but not for 3. So we can say that this number cannot be divided by 12. Let us now check the divisibility for some special cases, that is divisibility by 7 and 19. Now these are two peculiar numbers where we have a step-by-step procedure to find out whether the given number is divisible by 7 and 19 or not. Let us first take the divisibility for 7. What we do here is the given number is split into two parts. That means from the given number the units place is separated and the remaining part of the number is taken. Now the units place is multiplied with 2 and subtracted from the remaining part of the answer. And this procedure is continued till we get a 2-digit or a 3-digit number where we can easily observe whether the given number is divisible by 7 or not. Now if the number obtained is divisible by 7, then the whole number is divisible by 7. Otherwise it is not. Let us understand this with some examples. For example, here the given number is 224. Now how to check whether the number 224 is divisible by 7 or not? See, as such we know that 224 is 7 into 32. That's an easy example, but to understand the procedure, let us start with a simple one. So as I have mentioned, what we need to do here is break the number into two parts. That means units place should be separated from the remaining part of the number. So if we separate the units place from 224, we get 22 and 4. Now this number 4 should be multiplied with 2 and subtracted from the remaining part of the answer. So units place multiplied with 2 and subtracted from the remaining part. 22 minus 8. 22 minus 8 is equal to 14. And since 14 is divisible by 7, we can say that 224 is also divisible by 7. So that's how we check the divisibility for 7. What we need to do is separate the units place from the remaining part of the answer, multiply the units place with 2 and subtract from the remaining part. And this procedure has to be continued till we get a 2-digit or a 3-digit number where it is easy to observe the divisibility by 7. So if the answer obtained is divisible by 7, then the whole number is divisible by 7. Otherwise it is not. Let us now take another example, that is 16751, 16,751. So as discussed, units place has to be separated from the remaining part. So 1675, units place should be multiplied with 2, 1 into 2 and subtracted from the remaining part. So what do we get? 1675 minus 2 is 1673. Again 3 has to be separated, multiplied with 2 and subtracted from the remaining part. So we get 167 minus 3 into 2 is 6. 167 minus 6 is 161. After getting 161, if you are able to say that is it divisible by 7 or not, then you can directly understand the divisibility. Otherwise, continue the procedure for one more step. So again, by separating the units place, we get 16 minus, this units place should be multiplied with 2. 1 into 2 is 2. 16 minus 2 is 14. Now we know that 14 is divisible by 7. So we can say that 16751 is also divisible by 7. So that's how it is. Always in each step, separate the units place, multiply with 2 and subtract from the remaining part of the answer. This has to be continued till we get a 2-digit number. Let us now check this for 38274. So here we get 3827 minus 4 multiplied with 2. That will give us 38. 27 minus 8 is 19. So we get 3819. Again 381 minus this units place multiplied with 2, that is 18. So 381 minus 18 will be equal to 363. Again from 363 we can separate the units place. So 36 minus 3 into 2, 6 will be equal to 30. We know that 30 is not divisible by 7. So we can say that this number cannot be divided by 7. So that's how we check the divisibility for 7. Now coming to the divisibility by 19, the procedure here is similar to what we have done in case of 7. But the only difference is Instead of subtracting the units place multiplied with 2, we need to add the units place multiplied with 2. Let's take some examples and understand this. For example, here we have 399. Now 39 and 9 are to be separated. That means units place is separated from the remaining part. And 9 should be multiplied with 2. And this is added to the remaining part of the answer. So 39 plus 9 into 2 is 18. And this is equal to 57. We know that 57 is divisible by 19. 57 divided by 19 is equal to 3. So if 57 is divisible by 19, we can say that 399 as well is divisible by 19. Let us take one more example, that is 11096. Here we get 1109, 6 is separated, multiplied with 2. 6 into 2 is 12 and it is added to the remaining part of the answer. So 1109 plus 12 will be equal to 1121. Again, in 1121 we can take 112 separate and this should be added to units place multiplied with 2. 1 into 2 is 2. So 112 plus 2 is 114. Again, moving on, 11 plus, that means the remaining part of the answer, units place multiplied with 2. 4 into 2 is 8. 11 plus 8 is 19. Now 19 is divisible by 19. So very clearly even this number is divisible by 19. So that's how we can check the divisibility for 19. So 7 and 19 are similar to each other. The only point here is, in case of 7, we separate the two numbers. That means units place is separated from the remaining part of the number. Units place multiplied with 2 and it is subtracted from the remaining part. But in case of divisibility by 19, the units place is separated, multiplied with 2 and added to the remaining part of the number. And this procedure here is continued till we get a 2-digit number where we can easily check whether the number is divisible by 7 or 19 or not. Now after learning about the divisibility rules for the first 10 numbers and some special cases, let us now see how to in general decide that whether a given number is divisible by a particular number or not. So let's see the divisibility for other numbers. Other numbers like 14, 15, 18, etc. Now as we have seen, in case of 6, the divisibility rule for 6 is that the given number has to be divisible by 3 as well as 2. It should be divisible by 3 and 2. Similarly, in case of 12, the divisibility rule was the number has to be divisible by 3 and it should be divisible by 4. So let us understand how to decide which two numbers have to be satisfied for a particular number to have its divisibility. So let us now try to understand why do we take 3 and 2 for 6 and why do we take 3 and 4 for 12. Once we understand this, you will get to know how to check the divisibility for various other cases. Now to understand this, first of all we need to know what are coprimes. Coprimes. Coprimes or relative primes is a set of numbers where the highest common factor is equal to 1. For example, 5 and 3 or 3 and 5 can be taken as coprimes. Why? Because factors of 3 are 1 and 3. Factors of 5 are 1 and 5. Now here the highest common factor or the only common factor is 1. So 3 and 5 are coprimes. So numbers where the highest common factor is equal to 1 are considered to be coprimes or relative primes. Let us take one more example. For example, 8 and 9. Even 8 and 9 are coprimes. Why? Because the factors of 8 are 1, 2, 4 and 8 and the factors of 9 are 1, 3 and 9. As you can see here, the highest common factor is 1 for 8 and 9. So even 8 and 9 are considered to be coprimes. Likewise, 15 and 16 are also considered as coprimes. Why? Because factors of 15 are 1, 3, 5 and 15 and factors of 16 are 1, 2, 4, 8 and 16. So as you can see here, the only common factor which they have is 1 and 1 itself becomes the highest common factor. So 15 and 16 are also considered as coprimes or relative primes. The other important point that you have to observe here is coprimes or relative primes doesn't mean that both the numbers or all the numbers have to be prime. For example, in the first case, 3 and 5 both are prime in nature, but 8 and 9 if we take, both are composite. And similarly, 15 and 16 are also composite. So the point to be understood here is coprimes doesn't mean that both the numbers have to be necessarily prime. They can be prime or composite. The only condition which has to be satisfied is their highest common factor has to be 1. Such numbers are considered as coprimes. After learning about co-primes, it will now be easy for us to understand why do we take 3 and 4 as a divisibility rule for 12 and why do we take 3 and 2 for 6. For example, let us consider 12 here. Now to check the divisibility for 12, first of all we need to factorize the number 12 as a product of two numbers. That means we should be able to write 12 as a product of two of its factors. For example, 12 can be taken as 1 into 12, or it can be taken as 2 into 6, or 3 into 4. So these are the different ways in which 12 can be taken as product of two numbers. So out of these three cases, we need to take up that particular case in which both the factors are co-primes. And always factorization with 1 has to be neglected. So leaving out 1 into 12, the two possible cases are 2 into 6 and 3 into 4. Now out of these two cases, when we take 2 and 6, the factors of 2 are 1 and 2 and factors of 6 are 1, 2, 3 and 6. And the highest common factor here is 2. And since the highest common factor is 2, 2 and 6 cannot be co-primes. Why? Because for two numbers to be co-primed, their highest common factor has to be 1. So even 2 and 6 is ruled out. Now the only possible case is 3 and 4, and 3 and 4 both are co-primes. Why? Because factors of 3 are 1 and 3 and that for 4 are 1, 2 and 4. So since only 1 is the common factor, that itself becomes the highest common factor. So 3 and 4 has to be taken as the correct way of taking 12 as product of two numbers. Now that is the reason we take the divisibility for 12 as divisible by 3 and divisibility by 4. Likewise, we can understand it for 6 as well. Let us now take one of these numbers and understand what would be the divisibility rule for them. For example, let us consider 18 here. So as we have discussed, first of all we need to write 18 as product of two different factors. So 18 can be taken as 1 into 18, or it can be taken as 2 into 9, or it can be taken as 3 into 6. So these are the various ways in which 18 can be taken as product of two numbers. Apart from this, we have 6 into 3, which is same as 3 into 6, 9 into 2, which is same as 2 into 9, or 18 into 1. Now as discussed earlier, 1 into 18 has to be ruled out. Why? Because here if we take 1 and 18, the divisibility for 18 would be that the number has to be divisible by 1 and divisible by 18. That doesn't make any sense. Now out of the remaining two cases, we need to take up that particular one where the given factors are co-primes. 2 and 9 will be co-primes. Why? Because factors of 2 are 1 and 2 and factors of 9 are 1, 3 and 9. 1 is the highest common factor. So the divisibility for 18 would be that the number is divisible by 2 as well as it is divisible by 9. And when we take 3 and 6, we know that highest common factor of 3 and 6 will be equal to 3. Since the highest common factor is 3 and not 1, 3 and 6 are not co-primes. So the divisibility for 18 will be that the number has to be divisible by 2 and it should be divisible by 9. Likewise, we can check for the remaining numbers as well. For example, if you go for 15, we find that for 15 the rule should be that the number is divisible by 3 as well as 5. And similarly for 14, it should be that the number should be divisible by 2 and by 7. So this way, always try to factorize the given number into product of two numbers and then check which of these pairs is a co-prime. That particular pair can be taken as a divisibility rule for the given number. Let us now take the first example from model 3, which is based on the divisibility rules. The question here is, what is the smallest number that should be added to 89357 to make it divisible by 9? So we need to find out what number has to be added, what smallest number has to be added to this number 89357 such that it becomes divisible by 9. That means as of now, the given number 89357 is not divisible by 9. If we add something, only then it becomes divisible. So we need to find out what smallest number can be added so that it becomes divisible by 9. One way of solving the question here is to divide the number 89357 by 9 and find out the remainder. And depending on remainder, we can decide what has to be added so that the number becomes divisible by 9. But that becomes a lengthy procedure. Why? Because dividing 89357 by 9 itself may take about 10-15 seconds. So let us understand what is the smart way of solving the question here. We know that a number is divisible by 9 only when the sum of its digits is a multiple of 9. So let us first check what is the sum of the digits in case of 89357. So 8 plus 9 plus 3 plus 5 plus 7. 8 plus 9 is 17 plus 3 is 20 plus 5 is 25 and plus 7 is 32. That means the sum of the digits is 32. Now since 32 is not a multiple of 9, we can understand that the given number is not divisible by 9. Now the question here is what should be added so that it becomes divisible by 9. So let us first of all understand what should be added to 32 so that it becomes divisible by 9. We know that the very next number after 32, which is a multiple of 9, is 36. And 36 can be obtained by adding 4 to this number. So once we add 4 to 32, it becomes 36, and 36 is a multiple of 9. Hence, this number is divisible by 9. So very clearly, by adding 4, we get a sum which is divisible by 9, or which is a multiple of 9. So if we add 4 to this number, the sum will increase by 4. The sum of the digits will also increase by 4. And hence, we can say that the given number is divisible by 9. So the correct answer for this question should be 4. That means we need to add 4 so that the number becomes divisible by 9. So very simple point here is find out the sum of the digits and just check what should be added to this sum so that it becomes divisible by 9. The same number when added to the given number makes it divisible by 9. Similarly, let's see what should be subtracted from this number so that it becomes divisible by 9. Now as we know that the sum of the digits is 32, and if we subtract 5 from 32, this becomes divisible by 9. Why? Because 32 minus 5 is equal to 27, and 27 is a multiple of 9. So we can say that this number becomes divisible by 9 when we subtract 5 from it. So this is how we can solve questions related to addition or subtraction of a smallest number to the given number so that it becomes divisible by 9. Let us now take one more example which is based on the rules of divisibility that we have learned. The question here is, what is the smallest digit which should replace the star in the number 296 star 12 to make it divisible by 12? So that's an interesting question. We need to find out what should come in place of star in the given number such that this number becomes divisible by 12. And the options are 1, 2, 3, 4, and the fifth option is none of this. Now the given number here is 296 star 12, and this number has to be divisible by 12. We very well know that a number is divisible by 12 only when it is divisible by 3 and by 4. So let us go by the divisibility for 3 and 4 to check what comes in place of star. Let us first of all find out the divisibility by 4. We know that a number is divisible by 4 only when the last two digits is a multiple of 4. Now here the last two digits 12 is a multiple of 4. So definitely this number is divisible by 4. Let us now go for the divisibility for 3. So as the number is divisible by 4, let us now check for 3. We know that a number to be divisible by 3, the sum of its digits has to be a multiple of 3. So let us find out the sum of the digits in this case. As you can see here, the sum of the digits is 2 plus 9 plus 6 plus star plus 1 plus 2. So let us add all the digits here. 2 plus 9 is 11, plus 6 17, plus 1 is 18, and plus 2 is 20. And the left out value here is star. So the sum of the digits is 20 plus star. Now since we are checking the divisibility for 3, we know that this sum has to be a multiple of 3, or it should be divisible by 3. So we should find out that value in place of star so that 20 plus the value becomes a multiple of 3. And since he is asking for the smallest digit, we need to find out the smallest such value which can make it divisible by 3. Now if we go by the options, that is option number 1, we find that 20 plus 1, that means if star is equal to 1, the number becomes 20 plus 1, 21. 21 is a multiple of 3. So definitely if star is replaced by the number 1, this number becomes divisible by 3. Since 21 is divisible by 3, the whole number will also become divisible by 3. So that is how we can say that the answer for this question has to be option number 1, that is equal to 1.